All right, let's dive into one of the toughest, most high-stakes questions anyone in a major project has to face. How much is this thing actually going to cost? It's a question that can define a project's success or failure, but the answer, well, it's almost never just one number.
I want you to picture this. You're in the big meeting. All eyes are on you. And the boss says, we need the number for this new plant. The pressure is intense. But the project is still mostly just an idea, maybe a few sketches on a whiteboard. Giving a single number right now isn't just hard, it's a trap. Because really, you have two paths. On one side, you have risky guesswork. You throw out a single, premature number that immediately sets an expectation you can't possibly stand by. It's a recipe for disaster. But on the other side, you have informed decision-making. A structured way to talk about cost that accepts uncertainty and helps you guide a project from a vague idea to a successful reality.
So, how do we get from that risky guess to an informed decision? Well, there's a system for that, a really solid one. And that's what we're going to break down today. We'll start with that big question, introduce the 5-class system, walk through the journey from an idea to a full-blown budget, figure out what really makes an estimate good, and wrap up with why this all matters so much.
So this system comes from AACE International. That's the Association for the Advancement of Cost Engineering. These are the pros, the absolute authorities in this field. They created a classification system that gives everybody, from the engineers in the trenches to the executives in the boardroom, a shared language to talk about cost and, just as importantly, about uncertainty.
Now take a look at this. This is our map for the whole journey. It's the cost estimate classification matrix. You can see it lays out 5 classes of estimates. It starts at class 5, which is the earliest, fuzziest idea, and goes all the way down to class 1, which is the most buttoned-up, detailed plan. And if you look across the columns, you see how each class ties to the project's maturity, what you'd use it for, and of course that all-important accuracy range. So let's start where every project begins, at the very beginning, when it's really just a concept. This is the world of Class 5 and Class 4 estimates.
Okay, Class 5, this is the very first stab at a number, the roughest of the rough. We call this the ballpark estimate, the back of the napkin number. It's like asking a builder, hey, how much for a house? The answer is always, well, it depends. At this point, your project is barely defined, maybe 0 to 2% complete. You pretty much only know the basic concept, like the capacity of a plant and its general location. And this is where you really see the level of uncertainty we're talking about. This is used for really high-level screening. And that accuracy range, it's huge. It can be 50% lower or 100% higher than your number. So a project you ballpark at $100 million, it could realistically cost anywhere from $50 million to $200 million. Yeah, it's that wide. Now, as that idea gets a little clearer and we do a little bit of homework, we graduate to a Class 4 estimate. This is what we call the feasibility estimate. We've moved from just a vague idea to having some actual preliminary documents, like process flow diagrams. We're now somewhere between 1 and 15% defined, and we can start to seriously ask, is this project even a good idea? Is it technically and financially viable? The main goal here is usually to get a preliminary budget approved so you can keep developing the concept. The accuracy range gets a little tighter, but notice it's still really wide, -30 to +50%. We're still working with conceptual models, often based on the cost of the big, major pieces of equipment. Okay, now things start to get really serious. We're moving out of the what-if phase and into the let's do this phase. This is where a project becomes a funded, approved reality, and it's where we see Class 3, 2, and 1 estimates. This brings us to the Class 3 estimate. And let me tell you, for a lot of project owners, this is the most important number they will ever see for this project. So, why is it so important? Because this is the budget authorization estimate. This is the number that goes to the board of directors when you ask for the full funding to build the thing. To get to this point, you've got to have a lot more engineering done. We're talking 10 to 40% defined, with critical documents like preliminary P&IDs. Those are the piping and instrument diagrams, basically the detailed roadmap for the whole plant. You can see we're moving away from those high-level models, and we're getting down to semi-detailed costs for different parts of the project. That accuracy range is now getting into a moderate zone, say -20 to +30%, and that gives the people writing the checks the confidence they need to commit a massive amount of money. From this point on, this number is the baseline you'll use to control your budget.
And finally, we get to the most detailed estimates of all, classes 2 and 1. These are for when the project is really in the thick of it, during execution. A Class 2 estimate, which is based on up to 75% of the design being complete, is what a contractor would use to put together their bid. And a Class 1? That's the check estimate. With almost all the engineering done, it's the final benchmark you use to make sure bids are fair and to manage any changes along the way.
Okay, now I want to talk about what I think is the single most important lesson from this entire system. It's a fundamental concept that, honestly, a lot of people get completely backwards.
Just read this quote from the AACE standard itself. It says the class of an estimate is determined only by the maturity of the project definition. In other words, you don't just get to pick an accuracy range you like and call it a Class 3. No way. You have to earn a higher classification by doing the hard work, by doing the engineering and producing detailed plans. And this table right here shows you exactly what maturity looks like in the real world. Just take that one critical document, the P&ID. To have a Class 4 estimate, it just needs to be started. To get that big funding at Class 3, it has to be preliminary. And to get to a Class 2 or 1, well, it has to be complete. The level of detail in your paperwork is what dictates the class of your estimate. Period.
So if you remember just one thing from all of this, please make it this. More detail means a higher class estimate. That accuracy range you see on the charts, that's an outcome of the process. The defining input, the thing that truly matters, is always the level of project detail you have in hand.
So, why should you and your company actually care about all these classes? What's the big deal? Well, it's because this system is what turns project funding from what can feel like high-stakes gambling into professional, structured governance. It all really comes down to 3 huge benefits. First, it creates a common language. Everyone is on the same page about what an estimate actually means. Second, it manages expectations. No sane executive is going to treat a Class 5 ballpark guess like it's a firm Class 2 bid. And third, and this is the big one, it helps everyone make smarter decisions. It helps companies avoid those catastrophic budget blowouts by making sure the whole team is realistic about risk and uncertainty. And that brings us to one last thought. You know, this whole framework, it's not just for building billion-dollar plans. The core idea here of tying how certain you are about an outcome to how mature your information is, that's a powerful tool for thinking about anything. So I'll leave you with this question. Where else in your work, or even your life, could classifying levels of uncertainty help you make much, much better decisions?